You all know what time it is. Let's get to coding with Alex. All right, so today we're going to get into control flow with Rust, an essential part of any programming language. So stuff like if, else, for, and others. And we're gonna jump right in. To start, we're gonna do if, else, and let's jump to the code so we don't ruin the fun. I'm gonna read the prompt and then we'll get into cargo. So branching with if-else is similar to other languages, but unlike many of them, the Boolean condition doesn't need to be surrounded by parentheses, and each condition is followed by a block. If-else conditionals are expressions, and all branches must return the same type. Okay, so I'm going to create a new directory. We'll call it 0. I don't even know which one this is. I skipped a couple. I was a bad boy. I did them, I just didn't create repos for them. It's 08, flow of control. Okay. The others weren't video worthy. Let's just say that. Kind of dull. Not as exciting for programs to live code. But yeah, we'll just end it at that. Okay, so we're in our folder. Let's create a new cargo project. We'll call it if else. Let's enter into that directory and then get started. We'll open up the main.rs, remove the boilerplate. Actually, we'll leave that so that it auto-completes println for us later, and then we can delete that. I realized that about VS Code autocomplete. So to start, let's just initialize some variable binding. Not len, let n equals 6. And then get right into the if-else control flow. So if n is less than 0, our curly braces, curly bracket friends, print. Ooh, we're not using the println macro, we're using the print macro. Mixing things up. It's exciting. Okay. It is negative. And then, okay. Then else if n is greater than 0, print and else final condition, which would mean that n is 0. Print out that n is 0. Okay, and then we can just print out n, just so that we can know, even though we know. Okay, and then we can do cargo run. And so we can see 6 is positive. I guess it already put an n, so that last one that I put in was unnecessary, but cool. Sweet. So our program was able to do some mathematical comparisons with our if-else statement. We changed the number to about negative 99. Negative 99 is negative. Cool. Cool. Great. So now let's add a little more to our code, namely another variable. This time we'll call it big N. That's if N. Get a little tricky. If N is less than 10 and N is greater than -10, print. This time we're using the println. And is a small number increase tenfold ten times n. Cool. Else println and is a big number have a number n divided by 2. And we got a semicolon. And then finally, let's print out n and big N. And for this, I'm going to return our value of n to 6 and not have it -99. We can return it to -99 after it runs successfully the first time. I just don't want to risk it. So change it to 5 or 6, doesn't really matter. Okay, the cargo run. 5 is positive and is a small number, increased tenfold. 5 becomes 50. Cool. Interesting. So you can see how we can have this kind of nested if-else statement, which the variable binding depends on the if-else. So that's kind of cool. Let's change it back to -99. See what happens, and then we'll move on. -99 becomes -49. Okay, cool. Let's go. Who needs decimal points? You know what I mean? Okay, so I guess now we're gonna move on to loop. So let me change back into our main subdirectory for today. Create a new project called loop. Can't use loop. Loop. Flow. How's that? CD loop flow. Okay, the more you know. Loop does not go. Or whatever. Yeah. Can't use loop. Okay. Next, let's open loop flow main RS, and then I'll do a little bit of reading for a second and then we'll get into it. So Rust provides a loop keyword to indicate an infinite loop. The break statement can be used to exit a loop at any time, whereas the continue statement can be used to skip the rest of the iteration and start a new one. Okay, so let's bind a mutable variable called count, and we'll set it to 0 of type unsigned integer 32, and let's count to infinity. So I'll replace this with let's count to infinity. Hopefully my computer does not explode. So let's start this loop. So we're taking your count, which is 0 currently, and then we're incrementing by 1 And then let's do a condition, our flow, our if else, or our if flow control. So if count equals 3, println 3. Okay. Continue. Next. Println count. Okay. And then if count equals 5, print ln. Okay. That's enough. Dude. And then we're going to exit the loop using the break keyword, and then we're good to go. So you can see it's nothing too wild, but if we didn't have that break, man, we might be here for a while. So let's do cargo run. And you can see, let's count to infinity. 1, 2, 3, 4, 5. Okay, that's enough, dude. Sweet. On that note, let's move on to nesting and labels. So let me go back to our main subdirectory for today. Create a new project called nesting and labels. Enter into it or change into it, and then get started. So it's possible to break or continue outer loops when dealing with nested loops. Sorry, that was an awkward pause. I had to breathe. Let me say that again. It's possible to break or continue outer loops when dealing with nested loops. In these cases, the loops must be annotated with some label, and the label must be passed to the break continue statement. All right. So we're going to need to add a little helper for ourselves to tell the Rust compiler to chill out. So we're going to, because it's a little bit uptight sometimes. It's good. I mean, it's really good, but like we're learning right now, so we just need to enable some or disable some features. So we're going to allow unreachable code. I'll turn that off later so we can see what happens, but needless to say, it prevents some angry red error codes. So let's start out adding kind of a label to our loop, outer, and then use our println macro to output enter the outer loop. Just so we're kind of keeping track of where we are in terms of nesting. Next, let's label another loop called inner. Here we'll invoke another println macro this time to let us know that we're in the inner loop. Very cool. Now let's break the outer loop. And then the thing is, this point will never be reached because the outer loop was broken out of. Okay, and then finally, one last println statement. Sorry about that. Some good water. All right. So don't want to miss that semicolon. Now we can do cargo run and see what happens. So yeah, we got some warnings. That's fine. Unused labels. It's all good. So we enter the outer loop, then we enter the inner loop, and then we exited the outer loop. Okay, can we just break the inner loop? Oh, not into it. Okay, and then what happens if we remove that allow unreachable code? Guessing we'll just totally error out. Oh, it works. Interesting. Whatever. Okay, so just warning, yeah, this point is never reached. Okay, so the previous error was about this label not being used. Oh well, so let's remove that label. Let's remove that unreachable statement. And let's see if the compiler is a little happier with us. Much happier. All green, good to go. Okay. Next, we're going to return from loops. So let me create another cargo project. Enter that one, and then read a little bit. A blurb. One of the uses of a loop is to retry an operation until it succeeds. If the operation returns a value, though, you might need to pass it to the rest of the code. Put it after the break, and it will be returned by the loop expression. Okay. Let's experiment. So let mute counter equals 0, so just variable binding an integer. Let result equals loop, interesting, counter plus equals 1. Okay, so we're just incrementing our integer variable. If counter equals 10, break, return counter times 2. Interesting. And then we want to add in an assert statement to validate that our result equals 20. And let's see cargo run. No errors. Let's just, I mean, yeah, it's nice. Oh, oops. My bad. Yeah, it's 20. Okay, cool. Just wanted to double check. But yeah, sweet. Okay. Next, let's move on to while. So cargo new while looping. CD while looping. Let's open that main.rs and let me read some blurbage. The while keyword can be used to run a loop while a condition is true. So let's write the infamous fizzbuzz using a while loop. Oh, this will be fun. Okay. Let mute n equals 1. While n is less than 101, curly brackets, if n modulo 15. What the heck? 0. Print ln macro is buzz else if n modulo 3 equals 0, print ln, where is it? Oh, yeah, fizz. And then the other one is buzz else if n modulo 5 equals 0, print ln buzz, and then else the final condition, print ln, just the value. And then got to increment the counter. So n plus equals 1. And now we're good to go. So let's do cargo, run. Ooh. Typos. I got it. Mutable n equals 1L. Okay, it happens, man. It happens. Let's go. Nothing serious. Nothing serious. Oh, it worked. Nice. Okay, cool. Fizz buzz. In a world. Fizz buzz. Okay, cool. Next, we got for loops. Oh, we're making progress, y'all. Let's go. Cargo new for loops. Okay, speeding up. For n in 1 to 101. Oh, so we're doing fizzbuzz again. I'm in the zone. The for in construct can be used to iterate through an iterator. One of the easiest ways to create an iterator is to use the range notation a dot dot b. Okay, it's like 1 dot dot 101. This yields values from a inclusive to b exclusive in steps of 1. Let's write fizzbuzz using for instead of while. Okay, let's go. For n in 1 dot dot 101, if n modulo 15 equals 0, print ln Alex rocks. Else if preemptively curly bracketing. Print ln Alex. I'm actually Alex the third, so it's kind of appropriate. Else if n modulo 5 equals 0, print ln rocks. Else okay. I think we're good to go. Excuse me. Cargo run. Okay, alternatively, a dot dot equals b can be used for a range that is inclusive on both ends. And so we can rewrite our fizzbuzz. I'm going to copy this, comment it out, paste it just so we have both. Uh, update our for loop so that it's inclusive on both ends. And then we can rerun the code as such. Nice. We can also do or in construct is able to interact with an iterator in several ways, as discussed in the section on the iterator trait. By default, the for loop will apply the Intuiter function to the collection. However, this is not the only means of converting collections into iterators. Intuiter, iter, and intermute all handle the conversion of a collection into an iterator in different ways by providing different views on the data within. Iter, this borrows each element of the collection through each iteration, thus leaving the collection untouched and available for reuse after the loop. Intuiter consumes the collection so that on each collection, or on each iteration, the exact data is provided. Once the collection has been consumed, it is no longer available for reuse. It has been moved within the loop. And then Intuiter, this mutably borrows each element of the collection, allowing for the collection to be modified in place. Let's power through. Comment this out real fast, just so we can reuse the same file, because I'm a little lazy. fn main. Let names equals vec indexers, delegators, curators, developers. If you know, you know. Names.iter. Match name. Okay, reference to Ferris. Print ln. There is a restation among us. Comma. Oh, yeah, it's a match. Got to do commas. And then the catch-all. Print ln hello name. And then print ln names, and then the whole shebang with the debug notation to print out our vector. I forgot. Okay, there we go. Nice. So this is using our iter keyword. Let's go. Very cool. Next, let's use the Intuiter. I'm going to copy the same names because I'm a little... Actually, we can just copy the whole chunk just to save a little time. But we'll uncomment it. We can actually run for name in names dot into iter match name Ferris. There is a restation among us. And apparently this will just break. Let's see what happens if we leave it in. Didn't like that. Oh, because it's borrow. Okay. Ownership in Rust. Tricky, tricky. Okay, yeah. So yeah, because the collection's been consumed, it's no longer available for reuse after the loop, so that print statement fails. Interesting. Finally, let's do Intuiter. Name in names dot or intermute, excuse me. So we're gonna fancy. Match name. Oh, and then immutable Ferris. And then just hello. Interesting. Oh, so we'll just return hello. And then we can just print out our names. Let's go. It's not Intermute, it's Intermute. My bad. Okay. Still got an error. Oh, it's not a print ln, it's returning. Interesting. That's weird. For name, let. It's gotta be mutable. My bad. When copy paste goes wrong. And we're good. Hello. Because no one's named Ferris. Let's add a Ferris. There's a station among us in a world. Okay, cool. Next, we're going on to match. Let's go right into it. Cargo new match keyword. Rust provides pattern matching via the match keyword, which can be used like a C-like switch. The first matching arm is evaluated and all possible values must be covered. Let number equals 13. Print ln. Tell me about number. Match number 1. Print ln 1, 2 or 3, 5, 7, 11. Print ln. This is a prime. $13 inclusive through 19. Print ln a teen. And then the catch-all. Print ln ain't special. Okay. Let boolean equals true. Let binary. Actually, let's just run the first part. Car cd match keyword cargo run. Tell me about 13, a teen. 8. Cool. All right, let's add a little more functionality. Let Boolean equals true. Let binary equals match Boolean. False. 0. True becomes 1. Println Boolean binary. Nice. True becomes 1. 2 becomes 1. No, true becomes 1. All right. On that note, I should have stopped previously, but the section keeps going. So this is going to be a two-parter. But this is part 1 of Flow of Control. Part 2 coming soon. Thank you for hanging out, and really appreciate your company while we code together. It may be called Code Along with Alex, but I hope you're all coding with me, and I'm coding with you. So thanks for hanging out. Have a great day, and see you next time.